Now chill and sneak in here like this. I just told you now to close this breaker. I saw the synchronization. Yes, I saw the synchronization. Okay, so what's the other condition? We agreed that you should have Q1 or Q2 closed, and with Q9, it should be closed. Is that good? That's good if you're talking to me about the feeder. If it's a feeder without a transformer, meaning you don't have the downstream consisting of a transformer, then it won't be considered a transformer. It will be considered a line. Okay? So we said Q1 or Q2 should be closed, plus Q9 should be closed as well. Is that clear? And you went to the synchronization company and told me it's correct. There's one more thing left, right? What's left? If I come to you and say, well, your bus is live and your line is dead, will you close it or not? You'll say you'll close it, but I'll tell you to wait because you might have some issues. What are some of the issues you're talking about, Mr. Engineer? Let me tell you about these issues. What are some of these issues? First, the voltage transformer is supposed to transfer the voltage to the PCU or the LCC panel. Well, the first issue could be that the voltage you're receiving is 0, so you think the line is dead. Or if the VT of the bus is not working properly, you might mistakenly think it's dead. So why might it be dead? It could be because you've left the VT isolator open, which means you're isolating the primary of the VT from your line or your bus. Consequently, the voltage that reaches your PCU or your synchroscope in both cases will appear dead. Alternatively, you might have closed the isolator, but left the VT MCB open, which is located in the VT box at the JIS itself. Well, you might have closed it as well, but then you have to consider who is supplying the voltage to your system. That source might also be disconnected. Right? Isn't that the case? So I need to make sure that the VTI isolator is closed, the VT MCB box in the box is closed, and the VT MCB in the LCC is closed. In this situation, if the voltage I read through the PSU, the meter relay, or the synchroscope and TFR shows 0, then indeed the voltage reaching me is actually 0, because I have confirmed that all the connections are closed. But if any one of them was open, it means that the voltage that will eventually reach the PSU or the synchroscope is not a real voltage. It's clear, right? So there's no confusion in the interlocking or synchronization. Let's take a look at this step by step to see how the process works. So let's see, you have something here and it says, look, you have, the first thing is that KVT1 must be closed, KVT2 closed, and KVT3 closed. Who are these, engineer? These three are found on page 28. They are on page 28. Okay, I will go to page 28. Here's 17, 18, 19, and here's 28. Here's 28. And 19, this is 20, here's 28. Here's KVT1. Here's KVT2, and here's KVT3. All right, great. So where does KVT1 operate from? You'll find it gets a negative from here and a positive from here, and it will operate from this part. So which page is this part on? Page 20. Go back to page 20. Go back to page 20. Where is it? Here's 3 and here's 7. Where is it? Here's 3 and here's 7. Here's this, and keep going like this. Wait, this is page 21st. Page E. Yes, here it is. This is it. And here are 3. And where is this 7? Here it is. This is 7, which is column number 7. And here you have row number what? Row number this. So now I'm around this point. And this point, these are the 2 ends that are connected here, which will operate the coil of the contactor called KFT1. All right, great. Now look at this end. What is it? Here you have your voltage transformer. Here it is. Consider this your line, the line coming out from you. Here you have isolator 1, 2, 3 for the 3 phases. And here is your primary winding. And they are connected in a star connection. And you will always find them connected in a star connection. And here you have your secondary winding. In each video, you have 2 cores. Here is 1 core, and here is the 2nd core. All right, for each phase. So here is a core, and another core, and here is a core, and the 2nd core. All right, great. If you take a look at your loop, what will you find? It's like this, you see? You have this end coming like this, going like this. Here it goes like this, passes here like this. Now focus with me on the loop. I'll draw it for you with the red marker. So you're going like this, going like this, going like this. You passed this contact from the MCB. Continue like this. You'll go here, another contact. You'll go here like this. Another contact. You'll go here like this. Here you go like this. You'll go all the way there and come here like this. Turn around and come back here, taking this contact on your way, then this contact on your way, then this contact on your way, and then you return here to the other end. These two ends are the ones present on the page, which then operate KVT1. So KVT1 will operate when the entire path between these two is completed. Right, is this correct or am I mistaken? Okay, let's see what this path consists of. We said it consists of this contact being closed, and this one closed, and this one closed, and all of them in series. 1, 2, 3, 4, 5, 6. Whoa, all of these in series must be closed. So what are these? Look, you have, now isn't this the second winding? Come, you'll find this second winding. Isn't here like this and is cut off by an MCB, or their wires are connected through an MCB from... If this miniature circuit breaker, guys, is closed, then this contact is closed. We always said the miniature circuit breaker is drawn and its normal position is what? Open. So its contact drawn here is normally open when the MCB is open. Naturally, you close this MCB to supply power to your control and protection circuits. So this contact should also close. If you close the MCB of phase A or phase red, this contact will close. And if you connect the MCB of the VT for the yellow phase, it will close. And if you connect the VT MCB or the VT MCB of the blue phase, what happens to this contact? This contact will close. All right, great. So this is the set of MCBs present here. There's a box here, a black colored box. This means it's a mechanism box for the operation of the voltage transformer. All right, and who are these? Similarly, all of these are a set of components present in the box of the GIS. The purpose of this is that each of its gadgets, connections is made on it, and it is responsible for connecting and disconnecting the quality from these terminals up to the point. So these two terminals in the end are the ones that come to this page. If these two terminals are completed, the post will immediately come here from above, go down and activate the KVT relay. As soon as the KVT relay is activated, it will close its contact on the circuit breaker closing circuit page. All right, from KVT2, as you can see here, there's a box here that says it's from page 20 G6. Usually, you might find some text here above that can give you guidance or a guide to understand what this thing is about. Here, it tells you that the MCB is okay in the VT box, meaning that all the MCBs in the VT box are closed. Here it says MCP okay in the LCC band. So where is it talking about? On page 20. And which page am I on now? Page 20 what? So I go back to page 20. Where is page 20? We go to page 20, G6. So I come here, A, B, C, D, E, F, G. Here's G. And where is 6? Here it is, 6. I go down this column here, and it's talking to me here. Yes. LCC. C4. C4. Correct? What is this so we don't forget it? What is this that is located below us? Where what we have here, you will find a set of all that must be connected. What? They all must be connected, and of course these are all a set coming from or related to the distribution of what, or related to the distribution of what? The distribution of the VT circuits inside the LCC. Where is the MCB itself? Meaning the context of the MCB here. Where is the MCB itself? Here it is, isn't it? This was the MCB of the box. Now exit from the box. You exited from the box, and here you are in the LCC. You will find F1A, F1B, and F1C. These are all the miniature circuit breakers. One of them might be going to a spare. One might be going to an autocapacitor switch. One might be going to an AVR. One might be going to signal monitoring. One might be going to a protection panel. Monitor them and save them, for example, to the protection panel and save them to something else, and so on. Of course, all of these here are auxiliary contacts, normally open contacts from the set of miniature circuit breakers present in the LCC, which you must ensure are all closed. naturally, the normally open contacts are set so that when the MCC is open and when the MCC closes, all these contacts will close. So when all these contacts close, KVT2 will also operate. All right, who is VT3? If you look, you'll find a dotted line here inside a black box, which means it's a mechanism box related to the disconnector of VT611. Here it's talking about the VT isolator. All right, where is it located? 20A B2. Oh, I'm actually on page 20A. So where is B2? Here it is, ADB and AD2. If you look here, you'll find it's talking about this part. 33C and 34C are its terminals. 33C and 34C are normally what? Normally open contacts. So when the VT isolator is closed, this contact is also closed. This means that the VT isolator, according to rule number 5, tells you that the VT isolator is depicted in the drawing as being open. Therefore, all its contacts that you find in the drawing are referenced as if the VT isolator is open. Open. So when the VT isolator closes, this contact closes. When this contact closes, what does it do? It takes the positive from above and connects it to KVT3. So now I've activated KVT3, KVT1, and KVT2. One of them was activated when the VT isolator closed, and the other was activated when all the examples present in the VT box in the GIS closed. Another one is activated when all the examples present in my LCC panel are also what? They are also all. Okay, great. So now cavity 1, cavity 2, and cavity 3 are closed. You know, if one of these is different or not closed, then your circuit is open. So even if the relay detected incorrect synchronization or took a corrosion synchronization error or took an error, depending on the input it receives, it zeroes out based on the assumption that the input is indeed 0. However, this could be because, for example, the VTIM CB is open. So even if this is verified, you still have these 2 auxiliary contacts that won't close. Why? Because their auxiliary list won't operate due to their circuit being incomplete. Great. So these are related to the VT. What about my VT? Great. Then I move to D631, which is the line disconnector that should be closed. Here, the line disconnector is closed. Now, who is this part below? This part, engineers, is now telling you that you are closing in the service position. In the service position, you told me the disconnectors from before are closed along with the one after, right? But since you are dealing with a transformer, what are the conditions for closing the transformer? They are that we always close the high voltage side first, then we close the load side. If you are using a step-down transformer. So what happens is that I actually close the high voltage side first, then I close the medium voltage side, or what is referred to as the upstream, and then I close the downstream, right? So to close the breaker above in service, it must be ensured that the transformer is open from the other side. You must ensure the transformer is open, because if it is closed, the inrush current plus the no-load current will be drawn from it, and this will be incorrect for the transformer. So the conditions for the energization of the transformer are that we close the transformer from the upstream first, then from where? Then from the downstream. Here, this condition is presented to you as you see a box made. Also, what is written here is that it is coming to you from a 13.8 kV switchgear, and it provides you with the drawing number and the sheet number. If you go there, you will discover what these two are. I am telling you this because I like to study this when we study the other. The breaker Q0 is racked in but open, meaning it is ready to be closed or ready to be in service but not closed. It must be open. So I made sure it was open. Then I went down and found that I have the condition where either 627 is closed or 629 is closed. Okay, if 627 is closed, it comes down here and finds another contact in front of it. And if 627, wait a bit on this one because it's not there. It goes down here and finds another contact. Who is this contact? If you look, these are coming from those. Where are these coming from? Here, one is coming to you like this, and another is coming to you like that, passing through something called from where, engineer, are these coming to you? They are coming from you like this and made for you in a circle. This circle means where are they coming from? They are coming from the end, meaning from another cell inside. All right, so who are these? Do you see how this is? How is this? Sorry. Do you see what quality C and quality D are? I'll tell you what they are. If you go to this panel, you'll find out what they are. You'll find something called quality 1. quality 2, quality 3, just like the ones you had here. They are exactly the same. When all three are closed, they activate something called K. VTC, which stands for video teleconference, but you also have your own contact to ensure that his is also closed properly, and his V, meaning video, is also closed securely. All right, great. Now we fully understand this part and its significance in the overall process. All right, so now you have both closed, and if this is closed and that is closed, then both are clamped. So this is closed here, and this is also closed. Great, isn't it, engineer? Great. Now I'm asking you a question based on what I explained to you here in this synchronization. All right, based on what you understood. Now if I told you that Q1 is closed and Q2 is closed, because engineer Fadi is asking me if there's a problem if both are closed, I would tell you there's no problem, of course. So if both of these are closed, now as a breaker or a capacitor or a synchroscope, to check between the two voltages, one coming from the line side and the other coming from the bus side. Okay, the one coming from the line side, there's only one voltage transformer on the line side. As for the bus side, you have the upper bus and the lower bus, each with a voltage transformer. So should I look at this voltage or that voltage? Yes, this is the idea you have. What is engineer Fadi saying here? He is telling you that you just told me that you checked the data of your teleprotection and confirmed that your line disconnector is closed and that the downstream circuit breaker is open. Then you came here and told me there's something between the two. Either the disconnector D627 of the upper bus is closed or the disconnector of the upper bus is closed. Exactly. So if you look, if the disconnector of the upper bus is closed, one of the conditions you would check is that the VT of the upper bus is intact. What does intact mean? It means that the auxiliary ADI is working as a result of the VT isolator and the VT MCB, and the second VT MCB in the LCC and in the box, both are closed. So you were checking these conditions for K120 to operate. And if you had closed the other disconnector, you would go and check the condition of this cavity, which is related to the VT of the lower bus. But if this one is closed and that one is closed, yes, if both are closed, engineer, you see this is written and on D627. If D627 is closed, you will find this contact closed. All the blades are drawn in a position that indicates they are in a closed state. This is the fourth rule we set a while ago. When they were filling in the test position, as soon as you close the disconnector D227, it closes completely. So you are checking your circuit here, but at the same time, you took another normally closed contact from D27 and opened it here. Why? Because even if you close both disconnectors before the breaker, if this one is closed and that one is closed, this one opens here. So your reliance should only be on what? It should only be on checking the VT that is present on the upper side. Just that. This is in the case that both were what? Both were closed. Clear, engineer? Very good. So in the end, K120 or K120A or K120B, depending on your choice, K120A or 120B here closes one of the two. Either this one closes or that one, or this one closes. In the end, whether you are in test mode, which is the emergency state, or in local and remote mode, you came here, or in the emergency state, you came here. Of course, here in emergency, you close the breaker in the test position. And here, emergency or local remote, all together, you stop the breaker in the M service position. In the end, we all gather here to connect one point, which is the coil K28. K28 must engage with you as K28 is the big coil. The Institute, APK28, who is that?